So, good evening.
Good evening.
For those who didn't have been on my classes, I didn't know me. My name is David Stern, and I teach several classes at the school. So one of the classes is testing applications on the web. And there's actually some misconception going about this class, because a lot of people think that we are going to extensively test the browsers and hands-on testing on browsers. Probably not, because what this class is about mostly about the theory rather than the practice. Okay, but you should know that. You should know that in theory and how you're going to organize your test and how you're going to design the test. Because quite often you go to the company and they don't tell you, no, you have to do this, this, and this, and this. They say, you know, here's my application. Please go ahead and design how you're going to test it. Okay, and that will be on your shoulders to design the test and then come up with some ideas to the manager, saying, you know what, I plan to do this, this, and this because it should be done this way. Okay. Now, if you don't know the theory, you probably cannot come up with ideas. Okay, you can say, okay, let's do functional testing, let's do this, this, and this, but with a high risk of probability that you will miss some important steps and important piece. Okay. Talking from my experience, a while ago, you say 4 or 5 years from now, I was interviewing one guy who had 7 or 8 years of experience testing web applications. And he actually has a great resume, just whatever his resume. But when I asked him about to drill down into the details, he actually started to draw the graphs, you know, so you know, the graph goes this way, and I was testing, collecting the statistics here. I said, that's okay, but what actually you're testing, what this graph is showing? And he couldn't answer that. Literally, he couldn't answer that question. Okay? And he was very perplexed, very nervous. And the reason was that he had experience. I felt that. He had some experience, hands-on experience, but his understanding what was actually testing and why this graph should go this way and not the other way, he absolutely had very little knowledge, almost close to none. Okay, so that's another that's an illustration of the concept that theory here is very important. Okay, because most people thinking about web applications are actually opening a browser, navigating to the pages, logging into the page, you're verifying that your login is accepted or not accepted, depending on the testing you do, and then you go to the second page and then verify that the items which should be present there are there. Okay. If some people go ahead and actually verify that the user information, whatever you registered on a web page, is actually recorded into the database. Some people actually extend this test case, verify that the user can log in, but also they can go ahead and verify that this information is stored in the database, because most probably that this information, user credentials, are stored in a database, so you can go and verify that. But that will be partially more or less functional testing, where you'll use scenarios, whatever. But some test cases which are not applicable in the Windows applications are making perfect sense in web applications. And then web also has the specifics, and we're going to talk about these specifics during 10 classes. So actually 30 hours we're going to talk about specifics. Okay? So that's about theory. We're also going to have some hands-on experience with creating scripts. Okay? So we're going to create Perl scripts for testing web applications, or testing web pages, which might be very useful if you are going to do that. For example, for link validation, for image validation, for HTML code validation, we are going to create these scripts. And also we are going to test SOAP protocols. Okay, that's also a very, very big area, very popular area now. Okay, so you should be able to understand what SOAP protocol is and how to test it. Because a lot of companies are actually looking for engineers who could do that. Okay, we basically can come up and test SOAP protocols. Okay, that's also very interesting, challenging one. And during the previous classes, some people complain, some students complain that, you know, David, there's too much theory. Okay, can you actually go a little bit on hands-on testing? There is no little theory, okay, here in this case. So I just, while I was driving to school, a friend of mine called me, and I was teaching him Perl class. He was actually taking Perl classes. And I actually forced him to do some exercise, and he said, you know what, the other day I spent 2 days of my time just trying to solve this exercise. This exercise itself is not complicated, but for novice person, I realize it might be a challenge, okay? So he spent 2 days trying to solve this exercise, and finally he did that. And today he was on my interview. He just said, you know, I went on an interview, and they asked me that question, okay? So very close to that, not exactly that, but very close to that. And I was able to immediately answer that, immediately write the code, and people were impressed, okay? So if they asked me, say, several months ago, I could not do that. Okay, so it means that the time they spend, you know, he spent actually learning that, trying hard, had some effect. Okay, the same here. The theory which you learned here, it's not vanished. It's not just basically about trying to fill out some time here at school. It's very important because going to an interview, you might be asked questions first. Okay, theory questions, especially when you're talking about testing on the web, and now a lot of companies doing business on the web. They will ask multiple questions, millions of different questions about the web, and then without knowing the theory, you probably would not answer the correct answer. Plus, you might be in a situation when you start in the company, and they will ask you to design, write a test plan, for example, or design your methodology, what you are going to do. Okay, so that's also very important. You can search the internet, but you know that will take very long search until you can come up with some document describing what you plan. Okay. So anyway, let's start. We start from the history actually, from the human-machine interactions, because that's very important. But before going, continuing with that, can you recall what was your first email application? The very first time you registered your email and checked your email.
Juno.
Juno was web application or Windows? Windows applications. Okay, Juno. Come on, it's not a long time ago. Okay, it's not 50 years ago. Yahoo Mail. Okay, so that's web-based. Okay. Hotmail. Okay, some of you recall that these applications were actually Windows-based applications. Okay, and when I started and I sent my email in '94 for the first time, that was also a Windows application. Macintosh, I was working on Macintosh, so that was Eudora. It's a very good application, actually. And then with the time, nowadays, I think no one is using the Windows or Macintosh-based applications. And nowadays, everyone is using web-based applications. Reason? Reason for that?
You can update a web application faster.
Exactly. That's very good reason.
You can use it on any platform.
Good point. So you are not dependent on your machine, right? If, for example, you go to the work, if you go to some company and they say, you know, we're a Macintosh company, like it happened with me, and they give you a Macintosh, you still can use it, right? You can check your old mail, and the interface will not change fast, right? So slightly might be if you're using, say, Safari instead of Internet Explorer, you may see some differences, but nevertheless, you can do that. What else?
The only software you need is the web browser.
Sorry?
The only software you need is the web browser?
That's correct. That's also correct. Actually, there are several reasons which contribute to that phenomena when people preferring web-based applications compared to Windows or Macintosh-based application specifics. One of the major reasons is that versioning. For example, if you recall, you use Skype most probably, right? And you know that if you're using Skype and you didn't upgrade Skype, from time to time it has a pop-up message saying, you know what, we have this latest upgrade, would you like to update it, do you like to update it, and so on. Okay? It may be a good reason to update because it might be security patches there or whatever, but nevertheless, that's what you have to do. You have to go ahead and update that. And if you have limited disk space, don't like to buy this for some reason, then update might be problematic, because every update will eat disk space, right there. So, plus, you know, it might be also the case that the newest version is not compatible with something else. That's also a possibility. that's actually possibility we can run it. And second reason is that moving email applications into the web is actually presents several good features for us. For example, we're not dependent on a machine. Okay, we can go to hotel, say a hotel, and check, still be able to check our email. Okay, fully functional. We are not dependent on a machine or whatever. We are not dependent on the upgrades because whatever company is going to upgrade, they will upgrade on a server, not on our cloud, right? So as soon as they upgrade the server, if you have Yahoo account, you recall, but probably Yahoo updated their mail server maybe a year ago or less. They got new interface with JavaScript interface is actually much better than previous. Okay, so they keep updating that. Okay, not so often, but nevertheless they keep updating. If you use Windows version of the Yahoo Mailer, for example, then you have to download and update that, and then it will have to create a pop-up saying, you know, well, let's force people to update that. And then the upgrade also potentially problematic because if you run into the conflict, some conflict, for example, operation system, right? If the new patch is not compatible with Windows XP. A lot of people nowadays still use XP. And what if the new update is not compatible with the XP? You have to roll back, so you have to provide that mechanism, rolling back, and also you have to make sure that goes smoothly. Otherwise, people will stop calling you. Okay? Every single call placed at the company will cost at least $5. Keep that number in mind. Okay? So every time someone picks up the phone and dial the company, that will cost at least $5 for the company, if not more. Okay? So it means that if you do something wrong, you're going to lose a lot of money. Okay, plus a lot of dissatisfied customers. On the other hand, web is actually better in that case. You eliminate this problem completely, and then you actually not forcing the person to use another application. You are going to use the same browser, which people are already used to. Okay, that's actually a very good benefit. That's why when Hotmail was created, that was actually revolutionary. It started from Hotmail. Okay, they actually introduced this idea of having email on web rather than standalone Windows applications or Macintosh applications, because that was revolutionary. Okay, so now you are not dependent on a particular machine, you are not dependent on your application, on patches, whatever. Okay. So that's benefit of that, and then companies also realize that it's a benefit. So nowadays they are moving from computer or platform-specific applications to the web. Latest example is Microsoft. Microsoft is going to update Skype, which they purchased recently, into the Windows application. Because you know that Skype nowadays is Windows or whatever, mobile or Macintosh specific one. You have to download the specific executable and install it and then use it. But nowadays Microsoft plans to move it into the web. So you don't need to install this application anymore. What you need to do, you have to navigate to some site, which Microsoft will provide, log in there, and pretty much use it as you use your Skype nowadays. Okay? So it means that there is a tendency, it's a huge tendency, it's not started today or yesterday, to move applications which are typically existing on a specific platform into the web, because it offers a lot of benefits. A company which I work with, they decided, you know, I was kind of lucky because I was in the middle of that, almost at the start of that project, that participated in that. They decided to move a lot of applications, say 14 applications which existed on the platform on Windows, they were running on Windows, they moved into the web. And some applications are very complex, like they require a scanner and a handheld barcode reader. Okay? So I think what's a big deal, right? You just simply have the same scanner and barcode reader and then simply connect to the browser, but it's not the case. Browser cannot operate with scan reader. Okay? It's a tricky one. Okay, browser cannot reach these devices, okay, easily. So we have to rely on a software which is provided by another company, but with that software installed, you can do whatever you want. You basically can scan the document, and that document will appear in the browser. It's actually remarkable. So the reason company moved to the web applications from Windows 1 was actually deployment problems. The number of computers the application should be deployed was not huge. Maybe we're talking about, say, a couple of hundreds of machines. But every now and then, something happened. So operators were instructed to shut down or actually log off, not shut down, but log off from machines before they go home, so update can happen during the night. But some people either shut down the machine, so the machine was not reachable, okay, or they drove the application or computer into the state which is not responsible, not responsive, so it cannot actually do anything with that machine. Or they use incorrect login, which did not allow to do this. Basically multiple problems. And then cost of fixing these problems is enormous. Okay, so company actually tried different solutions, and eventually they come up to the solution that using these moving all applications into the web, having centralized server, then if you need to update the application, that update happens on almost on a weekly basis, then you don't need to push all these applications on these 200 machines. Okay, what you need to do, you need to just push it to one centralized server, and then every user who's going to log in after that will see this updated version without any problems. Okay? So starting with that, let's go to this user interface. So typically, a person working with the computer, we should work with the software through the user interface. Most probably that's a monitor, but that's not always the case. As I indicated, it might be a scanner, it might be handheld devices, and so on. Okay, and then data which user inputs, it might be also in a different format. It might be text, might be specifically file spreadsheet, might be specifically formatted text, and so on. Okay, so when we are talking about input, we are talking about data entries, data requests, searches, text editing, and so on. That's what we do on a daily basis without specifically asking that question, right? Output might also come in a different forms. It might be formatting, presentation, printing, or just putting information on the screen. Typically that's on the screen. We're talking about also logic, which might be very complex, working out the logic behind the screen. Okay, for example, if you ask a database what the prognosis for the sales next month or next year, right? The logic behind these calculations might be very complex because first of all, machine has to analyze what the perspective was. Maybe it has to take into account market situation globally, and so on, before it will come up with some prognosis. And based on that prognosis, you can make make decisions. Okay. And also, we're talking about a file system that basically where all data are located. Nowadays, it's very popular to store this information on a cloud, right? You probably heard that term cloud a lot of times, right? So what cloud is essentially renting space for putting your information there. For example, let's assume not many of you probably would have a lot of items at home so you need to rent a space from some company. You know that a lot of this business actually is booming. Okay, the renting space business is booming here, and what happens is that if you don't have enough room in your apartment or in your house, then you rent a space and put everything over there. And the company does not care what you put there as soon as it's not hazardous. Okay, so it will not harm the other tenants. And also it's beneficial for you too, because you know that if you have some garbage or some item which you are not ready to throw away, right? You say it's important for me for now, and you like to age it, okay? So you throw it a few years into that, later. Then you can actually put this item on a store, or this storage. Okay. So the cloud works pretty much the same way. Basically, what you need, you go to the company and say, you know what, my need is that I need, say, 5 terabytes of space. Okay, I need some space to store these 5 terabytes of data. Okay, it's not a problem just to go and buy the Disco Systems, a solution, and build that 5 terabyte system in your company. But it's not only the disk space, but it's also managing that. Okay, so you have to make sure that these 5 terabytes of data, first of all, they have constant power supply, right? So you have to make sure that this data is backed up, and also you have to make sure that it's operational and available, right? So you may think, okay, that's kind of coming by default. It's not the case. Okay, it doesn't matter what these companies will tell you. That's always going to consume some resources, maybe small resources, maybe big resources, but nevertheless that will cost you. Okay, so and then in some cases company decides, you know what, these costs are not applicable, I mean, it's not justified. So what we would like to do, we just like to rent this 5 terabyte of space from some other company, which provides us, first of all, backup, and will provide us instant access. Okay, so as if the storage is in our company. Okay, so that's not only regarding about this storage, I mean, disk space, but also regarding databases, regarding source control tools. You can store your whole repository of the tools on the cloud. You can store databases, basically everything you like. Okay, including emails. Okay, the company which I'm working now on, they renting everything. They don't have anything in-house. Okay, starting from email and ending with a file system. Even the repository, nothing. Okay, nothing is stored within the company. So it means that if the building is burned down someday, okay, if catastrophe happens, or a company moves to another location, it virtually will take no time to get connected. Okay, because nothing is stored, you don't need to unplug the machines and then restore it back, so everything is on the cloud. That's why it's called cloud, and also it has very good, another good feature. For example, clouds are scalable. Okay, let's assume you rented 5 terabyte of storage, and a few months later you decided, you know, we need another 5 terabytes to be safe, to feel safe, maybe another year or two. Okay, so what you'll do, you'll just file a requisition, right, request, and then it goes to the financial department, and then there will be a lot of discussions. Maybe a few months later, you'll get it, okay, in the best case, depending on the size of the company. If the company is huge, then it'll take more. If the company is small, usually this solved sooner. This problem is resolved sooner. But anyway, that will take the time and the resources to do that. On the other hand, cloud solves that problem, saying, you know what, you need another 5 terabyte, no problem. You can rent it at any time, starting from this very minute. Okay, when you hang up the phone, you can be sure that they added another 5 terabyte. And even more, say, you know what, you probably don't need to rent another 5 terabyte immediately. Maybe so immediately it's maybe 1 terabyte. Okay, so let's rent 1 terabyte, and whenever you run out of this space, we'll automatically add 1 more terabyte, so that will cost you less. So basically, you are going to pay per use rather than paying on fixed sums, like you do in the storage places. Okay, storage actually, if you're going to rent a storage space, you pay upfront maybe $30 or $40. I don't know how much they charge, but you pay it upfront, and then you can keep it empty. You can put it stuff over there. It doesn't matter. They actually charge you for the renting space. Cloud is not going to work that way. Okay, we are always paying for what you actually use. Okay, it has very big pluses. It also has constant problems. Okay, so there are problems associated with that cloud as well. But more or less, they actually solve it a lot of maintainability and scalability. These two problems are solved within the cloud.
But it would need a lot, a very powerful internet connection on the part, and then the cables, yeah.
They guarantee that. Okay, because typically what happens is that this system, file system or storage system, database system, whatever you're going to rent, they are placed in the data warehouses. Okay, and data warehouses, they have fiber optic connection, probably not even one. So typically it's not an issue. Okay, even if data warehouse is located on the other end of the country. Okay, we had that problem before. Say we had a warehouse in California, and the operation was done in say New York. Okay, and the problem is that the connection in New York definitely is fast because you go there and it's located near your warehouse. But in between, for example, between office in California and New York, you have to kind of be connected, right? And so in that case, you have to rely on internet service providers. In this case, most probably you'll go to the AT&T. Okay. AT&T can guarantee you, depending on the money you spend, okay, but typically they can guarantee that you have connection, and then they can guarantee that you'll get your data within, say, 90 milliseconds maximum. Okay, so, or depending on the contract. But this service is constantly improving. Okay, so at my time it was 90 seconds, so 90 milliseconds, sorry. And nowadays it might be even faster. Okay, no, if it is 90 seconds, definitely no one is going to subscribe to that.
I was wondering.
Yeah, typically that's what happens. Okay, so you get actually very fast connection, and you don't physically you cannot distinguish where your service is located. Actually, okay. So this service is constantly improving, so it's actually visible to you, whatever.
So what is the disadvantage of using cloud?
Disadvantages are if you have static IP addresses or your services depending on static IP addresses, then adding new service, for example, scaling up, might be problematic because you have to configure that. It's not simply just turning on another database machine and connect to that. Okay, so you have to actually connect to the, instruct the loader, the balancer machine and so on. So it's not simply just going and adding another box and then running. Okay, it's a little bit more complex. It might be, but it depends on the application. Okay, and
but that would be one time, right?
that's not, unfortunately not, because you can either scale up or scale down, right? So your operations, because for example, let's assume you decrease your load for various reasons. So you decided to remove that additional resource. Let's call it resource, okay? So you have to configure that as well, because if the part of the load is going to the not existing resource, then some of your customer will see as a non-existent. We'll get 404 error, page not found. Okay.
So isn't that the same case in dynamic IP addresses?
No. Dynamic IP addresses would not work this way. It's okay when you work at home and you don't host anything, but if you're doing business, you have to have static one, okay, or statically resolved. Say this way. Okay, you have to have that. So also depending on the application, you may require not even more than one static one. Okay, so it might be problems associated with that. Okay, but it depends on the intrinsics of the application. Okay, so covering this file system, and also this is how computers were operated not long time ago, say like in 70s and 60s. So people who were working at that time, they recall that they had a mainframe typically manufactured by IBM. And they have these terminals, and all this system was operating on the Unix, most probably Unix operation system. And so what happened is that they call it workstations. So you go on, you turn on your workstation on, and then you sending and getting back information from the main server. Okay. So if the mainframe is down for some reason, then none of these terminals will operate. Okay. So that's how it was operating. And also you should recall that the information was worked up, basically database was searched, your information was searched, and your request was worked up on the server. These terminals is essentially vacuum tubes with a keyboard attached. Okay, so no processing power and no advanced hardware was installed there. Basically, these were called terminals because they were. The sole goal of these terminals is just to get your input from the user, collecting the input, sending this input to the mainframe, and getting back the results. That's what it is. And all processing happened on the mainframe. Okay. Now this situation changed, and this is actually shown the evolutional spiral, which is applicable in the computer industry as well. So essentially, when the evolving say, and then progress happens, we're actually coming to the same place on the same level, but on a little bit higher. Okay, so essentially it means that we are reaching the same place on this on the floor. I mean, if you look at this part and this part, they're located almost on the same spot on the floor. You could project on the floor, but this second round is actually higher. Okay, so it happened in the computer industry, and I'm going to demonstrate that. Okay, so some people say there is no progress, but people are actually stepping up quite often. And that's a so progress happened when a personal computer was invented. I don't remember exactly was that IBM or Compaq or RA. Anyway, that was considered to be the very first personal computer, which was released in 1981, and computer had, I think, 4 kilobytes of memory or something like that, and that had 2 disk drives, and the disk floppy drives is actually really floppy ones with a 5-inch floppy drive, not 3.5 inches, which you probably so remember, but they were actually 5 inches floppy drives, and I had a box of these floppy drives at home, 5-inch floppy drive, this size. and they were pretty expensive. I had from '74 an open box, and that box cost $78. Okay, $78 for 10 floppy disks. Okay, at that time they were pretty expensive. Okay, and they actually amount of information you can put there. I don't remember. Probably a couple of hundred kilobytes, I believe. Okay, not more. So I didn't use them personally, but I know the capacity is limited. So what happens here is that computing power is actually located on this machine. Okay, so whatever happens, whenever instructions you put in ask the computer to perform, these instructions will be worked up on this machine. You don't need to connect to some other terminals or mainframes. So you can program games, you can actually type something here, or very, very basic games, you can program it and play with that computer. And also observe that this actually output comes in colors. Actually, green color and black is actually very, very, very modern at that time. So that was the beginning of the era, and then since that until recently, people trying to put more and more and more power into these personal computers. But personal computers actually also means one very important. It's called personal because only one person is working on it. Okay? So a friend of mine actually got this laptop, which is a very powerful laptop, and said, you know, my kid's actually struggling, who will get that laptop first? Okay? I say, in that case, you're not having personal computer. You have family computer. Because personal computer means that it's personal. It's very, very personal. So this is actually the very first personal computer because one person should work at this computer at a time. Now, so with the time, progress actually moved, progress happened, technology moved forward. And what happened here after that, we actually were able to connect these computers with a network, connected in a network. And using the internet, you can connect to servers which are located throughout the globe. Okay. So this happens when I think revolutionary start was paid by Cisco. Okay. Cisco actually they invented the router which allowed just this traffic to be connected together. And everything started with a printer because laser printers also came at that time, more or less at that time. And they were very, very extremely expensive. But on the other hand, if you print some document on the laser printer, it would look like it's out of the printing house. Okay, it's almost no difference. Okay, so that was so expensive, so consumers actually could not afford buying laser printers. It would cost $10,000 more, right? But universities could afford that. Okay, so universities could afford because they like to print the articles immediately without waiting, placing an order at the printing house and waiting a couple of weeks until that order comes. Okay, so you would be able to print this article very efficiently, very fast, and then present it. It's actually very, very catchy, like iPad nowadays, okay, or iPhone. Okay, it's a very, very catchy idea. And universities started to compete with each other, and they started to place the grants and ask federal money to buying these printers. Okay, but adding printers to the personal computer is no problem. The problem is that when you have several computers, and they actually have to kind of share this resource, network printer. Okay, that time Cisco came with a solution saying, you know what, if you put our router here, then your problem is resolved. Okay, you may connect as many computers as you want, and then you still can use this printer, and then all this stuff. Okay, so computers were organized in the networks and then finally connected to the internet. Now, with the time, that was the progress, and that was actually observed until recently. But remember the steroid? We're actually coming back to the original idea of having one main computer where all the resources will be, all data will be worked up, all the computing power will be located, and the idea of the terminals. Essentially, if you look at these terminals, monitors, not allocated to all them together like we have in a class, but actually physically separated in an organization, you will realize that maintaining these machines might be problematic, one thing. Okay. Second is that if you have laptops here, then you have to also provide the physical security of these laptops, okay, because they are still potentially another attractive for thieves. So a third reason I would say, even that if you are working in an organization and you need to install the application, then you have to actually make sure that everyone gets that application. in every single company I go, doesn't matter how centralized it is, still IT engineer goes from one laptop to another saying, you know what, did you upgrade it to the latest antivirus software? Okay, it happens. Okay, doesn't matter what. They may implement very complex script, they implement very complex mechanisms which will almost guarantee that, but still it will be some machine where the software, antivirus software is not installed for some reason. Okay, so it means that that person has to come and do it manually. Okay. Now, on the other hand, if you delegate this computing power to the central machine, which nowadays is becoming more and more compact and more powerful than before, then you physically can actually place these monitors, say terminals, that are slightly different than before, but nevertheless, in principle, they are the same. So they can connect to the server and then request some server power from the centralized server power and do the operations. Okay, make sense? Now, this is actually, this idea is the same, but a little bit upgraded. This idea was upgraded. You see that the small box is sitting next to the monitor? Okay, what it is? What is it? Small box. What do you think?
I think it's a very scaled down version of a hard disk or RAM, which smaller processing can happen here, and then I'm not sure.
Yeah, exactly, that's what it is. So essentially what we have in this box, we have the mini version of the computer, of the personal computer, desktop, but without hard drive. Essentially, a hard drive is taken from this machine. Okay, so this small box contains the processor, and it contains also input-output interfaces, but it lacks the hard disk. Okay, you cannot store anything from this machine. Okay, these small boxes can have operating system which are sitting on RAM. So as soon as you power them on, this operation system may start up. They may have different flavors. They have Windows operation system. They have Linux, Unix. They have that. But this operation system is essentially sitting on operation memory. As soon as you power it on, this operation system is available. As soon as you switch it off, all your changes, whatever you modify, that is gone. Okay, completely gone. So what happens here is that this box serves as a kind of an input device for user input. You can connect scanner, you can connect printer, you can connect audio, video, whatever streaming devices here, but you cannot have any personal data stored because all data is eventually stored on this centralized machine. Okay, and these boxes they call thin client. Okay, and this thin client. Compared with this machine is called thick client or regular desktop, normal desktop, they're called thick client, okay, fat client or thick client. Okay, these boxes are called thin client. Yeah, it's very popular because it provides some advantages, and the advantages are numerous here. Unfortunately, I could not present you with any thin client because I don't have any. I had before. So this is how it looks like. It looks like a wireless modem, the size of wireless modem. But it is not wireless modem. This is actually different versions of that. This is, I think it's from Apple. This is from IBM. Okay, this box like this size. Okay, it contains only input-output interfaces and then power button, and that's it. Okay, so as soon as you connect your monitor to this mouse and keyboard, you can connect anything. It looks like the output looks like interface looks like a normal computer interface, but it does not have hard drive. Okay. So as a result of that, maintenance of this software, maintenance of the operation system, which is specific to the company, becomes very, very easy. So definitely you can burn an image, and every time the client experiences some problem, you can go from one machine to another, from one customer to another, and install that. But with this thin client, you completely eliminate this problem. So you lower IT administration cost. It might be significant, okay, really, because you may say, okay, you bought company bought actually latest Windows 7 boxes, and they install that and say, okay, now everything is okay. But occasionally, a couple of boxes experience some problems with this, with booting and so on. Now, if you have a problem, which I had a couple of weeks ago, you have a machine, you boot that machine, everything is okay. 2 minutes later, if you don't do anything, machine freezes. Okay, you cannot do anything. That was a result of a failed sector in a disk. Okay, operation system is okay, but as soon as you hit that disk segment, it becomes non-responsive. So it took me a day to fix it, almost, okay, to figure out and fix it. Okay. Now, if you take one engineer, one day of IT engineer, maybe there will be a couple of machines. Next day he will come and say, you know what, we are on a tight budget, okay, so either your organization or your department should pay us, okay, for my time, or you should forget it. You have to take this responsibility and handle that yourself. Okay, that will what happen. You know, because every department has its own budget, okay, and you cannot actually borrow unlimited time, IT engineer time. Okay, you cannot do that. No one will allow you to do this. So in this case, you completely eliminate this cost because it's actually this centralized server. This one is actually sitting in a data room or probably in IT department, and they handle that. Okay, if something happens like this becomes bad, or should be backed up, or power is off, or antivirus should be installed, or latest patches should be installed, whatever. That's their headache. Okay, that's not your headache, not your department headache. You know that we were going to update it at midnight, so next morning you are going to have the latest version. Okay, so easier to secure. That's also very important asset because a friend of mine told me that he was working in. That was actually a funny story. He was he's working in one company on this day, and on the first floor, okay. And that company got very new Macintosh machines that day, so 50 new machines. And then he noticed that, you know, some very suspicious people walking outside of this building looking, you know, sneaking, trying to see what happened inside. So he reported that, but management didn't pay attention to it. That very night, I mean, they had a break-in company into this company. They opened basically a hole in the wall, okay, broke in, and took all these Macintoshes home. Okay, so that friend of mine said, you know what? That's what I told you. You know, you didn't pay attention to it. And what they had to do, they had to go and buy new 15 Macintosh systems. Okay, and you know what? They actually broke again. Okay, so that's installed a second time. Okay, so if you are using that, it shows that, you know, laptops or desktops still are attractive for thieves. But if you have thin client machines, these thin client machines are completely useless. Okay, even if you take that machine, you cannot use it unless you have server together with it. Okay, but server is typically physically secure. Okay, sitting in the data room with a couple of doors and locks. So this thin client is completely uninteresting. Okay, you cannot sell it. You cannot do it. Okay, just actually, as I say, it has negative value. So yeah, that's another thing. Enhanced data security. That's also another aspect which is very good coming along with this thin client, because the data is stored centralized. Okay, so if you have actually physically a central server physically secured, then you don't need to care about this thin client security, because there's no data there, and even if someone takes it, then not a big deal. Okay, you don't lose anything. You don't lose any information. You lose probably a piece of hardware, which is routed with a chip, and then no one can use it anyway. So lower hardware cost, that's also important, because this thin client, lower hardware cost is actually not so simple to calculate, because you have to buy a very powerful server, right? So if you are going to replace two desktops with this server and thin client, probably that will not be beneficial, okay? Because that will be buying two separate desktops will be a cheaper solution than buying one server and two terminals, two thin clients. But if you're going into the 1 to 10 solution, for example, if you're buying 10 thin clients and one centralized server, definitely you are going to save a lot. Because this thin client costs approximately $250 in average. Okay, so it's definitely much cheaper than normal desktop. Okay, and also there are few moving parts in this thin client, which also are very beneficial in many cases. So, for example, if you're working in a room with 10 machines, desktops, you know sooner or later they become noisy. okay, because these fans which are sitting on the cooling devices, okay, they should be greased from time to time. And no one does that, so you have to replace it, but no one cares about it. So it means that sooner or later you have to live with the noise. So these thin client, they don't have moving parts. So it means that they don't produce noise. Okay, they're quiet. Anyway, when they develop, when they manufacture the computers, so what's the lifespan of the microchip? What do you think? So they manufacture microchips, right? These hardware companies, and what they're planning lifespan of a microchip.
Year?
2 years.
2 years.
Okay, so that's what they plan. It means that if you have a computer which lasts more than 2 years, you're essentially having bonus. Okay, on this hardware manufacturer. That's how it is. So, and then in the companies, typically, if you work in a company for long, you realize that after 2 or 3 years, they will replace hardware, okay? Because they got new powerful machines, and most companies, actually big companies, they don't buy the machines, but they lease them, okay? So overall, lease costs a little bit more, but on the other hand, they actually eliminate a headache of replacing parts, and they don't actually overload IT department. As soon as some problem with the machine, they basically return to the company and then get new one. Okay, so this happens on a 2 or 3 years basis because they realize, you know, if the microchips lifespan is 2 years, then it's probably the time to replace it. Okay, so the replacement of the thin client is cheaper. Okay, plus thin client typically lasts longer because they don't have heating parts and they don't have moving parts. And then have vibrating parts, whatever. So it's basically the input-output terminal, and as such, it may last longer. Okay, you have actual benefits here as well. CPU utilization, this is also the benefit of this one. Oh, I'm not going to read through all of this. You can have slide 15. Less energy consumption. People nowadays getting crazy about green, okay? You can actually add this item, this bullet point to the idea. Typically, yeah, it costs less because, first of all, energy management is very quick. You don't need to shut down the thin client. You basically turn the button, that's it, it's off, okay? So you don't need to wait, and it's not power cycle, it's virtually zero. And it consumes less Plus, you know that if you have a room with multiple machines and multiple desktops, you need to cool it down. So every day in December you go, it's actually nice to visit on the summer day. Because it's really, really cold there. But that cold costs time, costs money and the resources. Typically, say if you like to cool the room by 10 degrees, it costs 3 times more than to warm it up 10 degrees. So actually cooling is 3 times more expensive than heating. Okay? So you realize that there's actually more area cool down, it costs you more. Okay. So failure management, pretty easy. Just basically replace that without any problem. Just not troubleshoot. Work less to most thieves, actually negative value. We cover that. Operable in hostile environment. This is also very important for some companies. For example, chemical labs or hazardous industry. This company, this thin client can be hermetic. I mean, completely isolated, and since they don't have fans and cooling devices, whatever, they don't need air intake and output for air. So you can put that there. Okay, so they can perfectly operate there. So if you worry about that, okay. So less network bandwidth, this is a slide which describes that. More efficient and computing resources depending on the task, typically it is, but not in all cases. Okay. So simple hardware upgrade time, this is actually very important because if you need to add more disk space, more CPUs, upgrade the RAM, it's done centralized in only one place. Okay. So as a result of the architecture. Lower noise, less wasted hardware, So with the time, they will increase this, how they call it, waste tax. Whatever. Every time you buy new hardware, they actually add additional tax. If you bought laptop or desktop recently, you saw the probably will present that this tax is actually more than before. So it means that it's going to cost more because it takes resources to utilize this hardware. So since you have less hardware to utilize, to recycle, then the tax will be lower. So for the company which has hundreds of machines, it definitely will be cost. Okay. So now we're going to cover client-server computing and client-server operation. This is actually also a lot of misconceptions about that, a lot of wrong ideas about this topic. What happens is that web, as we know it in present form, is a typical example of client-server environment. Okay, so whenever you have desktop with the browser sitting on that, you are a client, and then you send a request to the server, and you get response back. But that's a particular case. Some people argue here at school, say, you know what, that's not the case. Web is web, but client-server is something else. It's not the case. The web is one particular example of client-server architecture. Okay. So what happens is that you send a request to the server, and all this data is worked up on the server. Some processing happens on the server, and then you get a result back. Definitely, this is in simplistic form. In reality, it might be complex. For example, processes which happen on a server might be very complex. I mean, it takes very extended period of time to calculate, or even more. You probably heard about the SaaS, right? SaaS. Okay. SaaS. It's a software as a service. Okay. So what happens is that you have a software located on a server, and then you use it as a complement. It's basically as a cloud. Okay. For example, one good example is Google Documents. Right? You typically, when you need to create a document, you have Microsoft Word document open. You create a document and save it locally. Right? But you know that we have also web solution for that. Okay, we can go and create the same document on the web, and even more, we can give other people privileges to edit that, attach comments, basically make a collaborative efforts to creating this document, particular document. This is one example of software as a service. You're actually using the text editor as a service. Okay, it's not your personal copy. It's not located on your machine, but it's located on the net, and you use it. You actually borrow it. Okay, it's also a very popular idea. So this is the long answer about client-server computing, and I'm not going to cover that unless you have very like to read long statements. But this is official definition of it. Okay. So let's start with the client processes, because some processes may take place on a client machine. For example, the typical example which we faced before is JavaScript. Remember, we had JavaScript, which was capable of validating user input. We, in the JavaScript class, were validating user input for credit card. Okay? And we created a script which was able to validate that the credit card number was 16 digits. If it's not 16 digits, it was just an error and didn't send a request to the server. Or also we can validate that all this information which user typed in the credit card are numbers, are digits. Okay? So there's no alphabetic characters or punctuation characters inserted. This happens because we had a client process, a client JavaScript, which was able to do that. Okay? So, and then client programs typically, we're talking about from the web point of view, are they handle user interface portion of the application. Essentially, most probably validation. Okay? You can also, not only validation, but what also may happen is that you like to rearrange some objects on the web page. Okay, this client application will allow you to do that. For example, you have several components located on a page, and you don't like the arrangement. You actually change the locations. This is handled by JavaScript sitting on your client machine. Unfortunately, I don't have examples to show, but you have to trust me. Okay, so And that client-based processes are typically, that's what the front end when the user sees them, okay? And if they actually misbehave or don't work correctly, that's of course you notice that, okay? Not the IT engineer on the server side, okay? You as a user will notice that immediately. So, and then client processes which are sitting on the client machine provides only portion of the computation which should be performed, in the best case. Okay, sometimes they don't do anything much about the computation, but even if they're present, they do a portion of it. Okay, because major part of the computation happens on the server side. For example, if you request historical data from, for example, like earthquakes in the Pacific region, right? So you're investigating this phenomena, you're requesting this data. So first of all, when you enter this data, client machine or actually web page may actually validate that the region you requested is correct. For example, if you specify the area and then you may specify by geographical coordinates, it may validate that these coordinates are entered correctly. But that's as much the client machine can do. In order to retrieve this data, you have to send a request to the server because this information is stored in a database and it's not available on your laptop or desktop. Okay? You have to make a request. Now, the server receives this request and then it processes data and returns back to you. Okay? So the client process is a limited one. Okay? And it also can manage local resources. Also, not in all cases. For example, JavaScript cannot handle your disk information, disk space information. For example, let's assume you're requesting that data about the earthquakes, historical data about earthquakes. Okay? The amount of data which you receive might be huge. Maybe let's say 300 megabytes. Okay, such all this information, historical data. But you may not have this 300 megabytes in your disk space. Okay. So JavaScript, which will validate that, it can even tell you if you have enough disk space to do that. Download will start, but at some moment of time that will be terminated because you will be running out of space. Okay, so this is done on purpose because JavaScript should not have access to your local resources. Otherwise, it will be very big security breach. Okay, JavaScript cannot validate your disk space. It cannot write or read anything from disk space except cookies. Okay, cookies is one exception to that. So that's example of that. So when I say that the client processes can manage local resources, you have to be typically it's limited. Okay. So now let's talk about the server processes because the majority of the operations or validations of data workup happens on the server. Typically, when you go and start working in a company, you will see that a QA group is divided into two parts. Okay, that's what you observe. If you go to an internet company or company which is doing business on the web, they have two groups. One group is working with the front end, essentially testing the application, interface of the application of web pages, how they look like and how the outside world will see them. And this group is basically busy with testing the web pages, testing functionality, and so on. And then there's some kind of a hidden group, or even, not physical, so they call it backend group, okay? So they call it server group or backend group, whatever. And the amount of work they do is huge, but it's not immediately visible, okay? What they do, they have to test the servers. They have to test all these processes which happen on the server, including the one which you're requesting, actually the web interface group sending to them, okay? And their testing, actually, their job is more challenging and more difficult in many cases. Okay, so that's why probably this group is better stuff than front end. Okay, so what happens here is that server process fulfills the client request by performing the task requested. This statement is actually two lines of words. Is actually, it might be tons of activities behind these two lines. Okay? Server might do very complex tasks. It may actually connect to the database, may connect to several databases, may actually collect this data, may compare this data, and present final workup. Sometimes it takes a substantial amount of time. So if you order online tickets, flight tickets, online, you may notice that sometimes server is not responsive within a couple of minutes, okay? Because amount of work it should do is actually huge. And sometimes if you like to compare different companies to each other, okay, then it takes even more time, okay? Because amount of work, especially when you're indicating very fuzzy ones, like for example, couple of days plus minus couple of days from the from your departure date and arrival date, then search is very complex, okay? Because more data should be worked out.